Hello, my name is Alexander Votyakov and I'm a teacher of mathematics. So here's the task that we're going to solve today and we will discuss it thoroughly. It is one of the classical tasks in Russian Olympiad mathematics. The topic is the so-called reverse analysis. Let's proceed to understanding what it is all about. So we have one lily on the lake on the first day, and then every day the number of lilies doubles. This means that after one day we have two lilies. On the first day we have one lily, on the second day we have two lilies, on the third day we have four lilies. So each day we have to multiply by 2 the number we have in front of us, and we have to do this like 20 times. So the first intuition would be to keep going and just, count what is the next number. What do we have after only 8 days? We have 128 lilies. So it seems possible to count forward up to the 20th day, but it is kind of hard. I mean, it gets hard after like a couple more days. Just check it out. On the 9th day, we have 256 lilies. On the 10th day, we have 512 lilies. On the 11th day, we have 1024 lilies, which is the power of 2, so-called. Like it is 2 by 2 by 2 by 2 multiplied 10 times. If you're familiar with powers, you can just say that it is like 2 in the power of 10, but actually this task is more like on general reasoning. It's not about counting at all. I mean, you have to count the number of lilies that is going to be there on the 20th day just to understand on which day the half of the lake was covered with lilies. If you keep going, it is going to be like too much. The numbers are going to be big. Like on the 15th day, it's going to be a lot more than 1,000 because it's going to be multiplied by 2 4 more times. So it's going to be somewhere around 16,000, something like that. And it is very hard to count these kinds of numbers, especially if you have to do it without writing it down, just in your head. And this task is totally solved just in your head, without calculator, without anything, just with your thinking. So your second intuition would be just dividing day 20 by 2, because on which day half of the lake is going to be covered with lilies. So probably if we have like day 20 as the last day, then probably we're gonna have day 10 as the half day or something like that. But we already see that on the day 10 we had 512 lilies. So this means that if this is half the lake, then full lake is going to be covered by day 11. And this is where you see the idea of the task for the first time. If the number of lilies doubles every day, this means that, like, for example, between the day 10 and 11, you have like doubling of the number of days. So if you see that the number of lilies doubles every day, if you assume that half of the lake is covered with lilies on the day 10, and then you proceed to understand that this would mean that on 11th day, full lake is covered by the lilies, and then it is like too soon because you have to wait up until the day 20. This means that if you go in reverse from day 11 to day 10, you're going to get half the number of lilies you had on day 11. Check this out. If you go from day 7 back to day 6, you have to divide by 2. This is how it works. If you have to double the lilies every day, then you can rewind time, like time travel back one day, and you are going to see the number of lilies halving. This would mean that if the lake is covered by lilies, totally covered by lilies on day 20, what is the day that the lake is covered by lilies only in half? Just try to reverse one day from the last day. You're going to see that if the full number of lilies on the 20th day is, let's say, 1,000,000, we don't really know the number because we're too lazy to count it. We don't want to use the calculator or whatever. Just try to put any number there. We don't really care. We don't need the number itself. We need the day. So if we have 1,000,000 on the last day, when will we have 500,000 lilies? And this way, this task becomes very obvious. You're going to have 500,000 lilies on day 19. because this is where the half is. This is 1 day backwards. You have to divide by 2 if you go 1 day back in time. So this is one of the very classical tasks, and this task is solved incorrectly by most of the adults. When we're talking about Olympiad mathematics with children, this usually means that after like half a year or maybe like even 3 months of studying mathematics, children who study Olympiad math, they become way smarter than most of the ordinary adults. Meaning logic, meaning problem solving, meaning tasks like that, like understanding the idea of reversing is just one of the small ideas. There are a lot of different areas in mathematics, and I don't mean like hard mathematics. I don't mean hard math. I don't mean tough arithmetics or something like that. I don't mean trigonometry. I don't mean calculus or like stuff like that. Like mathematics is not hard in itself. It is very interesting. It is mostly dealing with these logic tasks, with things that could be understood by a toddler, like things that are easy to understand just by looking at words, looking at concepts, not thinking about big different constructions that are like piled in on itself. The math you are studying at school mostly consists of instruments. It's the math you use to count things, the math you use to solve equations and do this, all this other stuff that you are required to do by the school. But the core math, the math that all this school arithmetics, let's say, is built on, mostly deals with logic. The math that you are going to study if you are like deliberately going into mathematical departments in university is going to be more like this. This is the real math. That's the math that develops your brain, the math that actually makes you think. And if you are able to do that, if you are able to think, then you are able to understand all the simple school math very easily. I mean, it's really simple for an Olympiad mathematician to understand all these complex equations and like the beginnings of calculus and whatnot. Because most of the hard things in math, in school math, it is not hard because it is complex, but it is hard because you lack the logic to understand complex things. Actually, all the math that is that you are studying while in school is like super simple. It is very easy. You can learn all the school math like in a couple of years. You don't really need like 5 or 6 years for that. But the problem is that the student that is studying this math in the very beginning, well, let's not say that he's stupid, but let's say that he cannot deal with abstract structures in his head. The average student cannot understand math quickly and easily and doesn't really love math because he does not see that math is not about these symbols. It's not about like plus and minus signs. It's not about multiplication or like division or whatever. This is like saying that literature is about words and well, even letters. Letters are definitely the thing you have to know if you want to read. And like the ability to read is definitely something you base your literature on, but literature is way more than that. And it is way more interesting. And it deals with concepts, with ideas, with all this stuff that you are only able to grasp if you can read. Of course, you have to learn to read to understand literature. So you have to learn to count, to try and solve these kind of tasks. But these tasks are not about counting. They're not about math as you're used to perceiving it. Math is mostly about ideas, about solving something hard, something very mixed up in itself. And I don't mean mixed in terms of lots of signs or lots of variables or whatever. I mean mixed in terms of ideas. And these ideas are fundamental. So that's why you would have to learn math. Let's proceed to another example of thinking about reversing the task to understand it better. While the first task was not so obvious as to like quickly understanding that it is all about reverse, I mean, it was about growing lilies, and lilies were doubling every day and so on and so forth, and you would have to somehow figure out that you are going to have to reverse, because on the 20th day you've had full lake, on which day you've had only half a lake, and you would assume that you have to count first. And then when it proves to be too hard, you would assume that you have to use some heuristic like divide 20 by 2 and get 10, and only after a couple of more steps you are understanding that you have to reverse. Here the reversal itself is natural, it's very obvious from the task itself. Take a look. On the first day I spent a quarter of my money. How much money did I have at the beginning? I don't know, and that's the question of the task, how much money I've had in the beginning. On the second day, I spent a quarter of remaining money. That's not the quarter of full sum, it's the quarter of remaining money. Notice that you already have less money after the first day, so you are spending quarter of the lesser sum. On the third day, I'm spending half of the money that were left after the second day. And then on the fourth day, I'm spending the remaining $9 and I'm completely out of money. So, how much money were there at the beginning? After reading that task, it is pretty obvious that you have to reverse. But how do you reverse that? You have to go day by day from the end back to the beginning. You don't go like, okay, how much money could I have, like $100? Oh, let's try that. On the first day, that would be minus 25. That would leave me with $75. And then on the second day, I cannot really count the quarter of 75 because 75 is not divisible by 4 and it gets hard. And I'm like, what? How would I solve this? Do I have to guess the number? No, guessing is definitely not the way to go. You have to somehow understand how can you count the number that was in the beginning using only the number that is left. So you have $9 in the end. After the third step, you're having, like, let's say that we don't really know the number we have at the beginning. And then we subtract a quarter, like let's use the word quarter, and we have like some other number. And this other number, we subtract the quarter again, but it's already a different quarter. It's a quarter from this number. And we then get another number. And then when we use this new number and subtract half, we get $9. Because on the fourth day, I'm spending $9 and I'm completely out of money. So that's gonna be it. We have to reverse the task and one by one figure out which numbers were there on the places that I skipped. So if we subtracted half and got 9 out of it, how much money did we have in the beginning of the third step? After we subtract half, we get $9. Before we subtracted half, we had like some bigger sum, obviously. And then when divided by 2, we subtracted half. So the remaining half is $9. So the full sum should be 18. $18 minus half obviously means 9. If we subtract half of the money, then to reverse this action, you have to multiply it by 2. To reverse $9 back to 18, you have to multiply it by 2. So we've had $18 as the remaining sum after the quarter subtraction in the second step. How much money did we have before subtracting a quarter? This is a tricky question. It's not about halving, right? Maybe we could like multiply by 4. Maybe this works. If we are subtracting half and we get 9, so we have to multiply by 2. Maybe subtracting quarter would mean that we have to multiply by 4. Well, let's try it and see if it works. If we multiply 18 by 4, we're gonna get like how much? 10 by 4 is 40 and 8 by 4 is 32. These are the things I'm doing in my head. So in my head, it looks like that. It's 40 plus 32. I'm actually not really counting that because I remember the multiplication table. So 10 by 4 is 40 and then 8 by 4 is 32. So what we get is 72. And actually I'm skipping this step too because I don't really need to remember two numbers. This is very easy for me. So when I'm multiplying 18 by 4, I'm multiplying it all in my head. So it's 40 plus 32, so it's 72. That's it. That's how it works. And it's really fast. So we have 72. And when we try to do the second step with $72, we go 72 minus a quarter. And how much would a quarter of 72 be? This would be $18. And then we have to subtract 72 minus 18, and obviously we are not going to get 18 out of it. So if we subtract a quarter and we have $18 left, we cannot obtain the sum that was in the beginning by multiplying 18 by 4. That's obviously not how it works. Then how does it work? How would we see the sum that we had before subtracting a quarter if we are to get $18 in the very ending? I mean, can we draw this somehow? Can we understand it better by providing some visual understanding? Maybe if we have the total sum, like as a big sausage, let's say, and we are subtracting a quarter from it, we have to divide this sum into 4 parts, 4 equal parts, this sausage, let's say, and then subtract a quarter of it, and then we would have $18 remaining. So $18 is 3 parts. This would mean that every part is 18 divided by 3, so it's 6. So we have 6 written down on every part. This would mean that the 4th part that we subtracted was also 6. This would mean that the total number is 24, 6 by 4. And 24 minus a quarter equals 18. This is actually so. So we reversed the second action. Now on to the first. We write 24 here, and we have to find the answer to the task. So the sum that was in the very beginning before we subtracted a quarter from it. We can do this just in the same way. So we've had a total lump sum that was divided by 4 parts, and we subtracted a quarter and we got 24. So this means that every part is 24 divided by 3 equals 8. So 8 here, 8 here, 8 here. This would mean we have 8 here too. So the total sum would be 24 plus 8. This means we had $32 in the very beginning. And that's the answer to the task. How much money I've had in the beginning? 32. That's it. That's how you do the reverse. Feel free to subscribe to my channel and like the video. Probably you can ask me any questions in comments section. I'm going to answer. That's my first video on this channel, so I don't know. Excuse me for my accent. I mean, it's obviously a little bit influenced by me not talking English for a long time, but I think I'm going to be getting better at it with the more videos to come. So, I mean, hello and welcome to the magnificent world of mathematics. I'm going to lead you all the way there with a lot of lessons, hopefully. And let's see to it that this video gets promoted by the YouTube algorithms, and a lot of people are going to see this, a lot of people are going to subscribe to the channel, and we are going to make this into something big together. Thank you for watching and see you around. Goodbye.